Hello, this is the group from Customs 2, and our project is the Hydration Monitor Wristband. We're composed by Fabiola Pons, Jose Martinez, Engineering Alex Velez, and myself, Gabriela Lugo. Now, in the outline, we have system integration plan, the manufacturing and integration assembling plans and procedures, system operation plans, that is the user manual, the performance estimates, the system budget, and the project plan, that is the tracking. Now I'm going to leave you with Jose Martinez, and he's going to talk about the system integration plan.
Yeah, the system integration plan includes the energy efficient low power system with rechargeable battery. The energy consumption will be less than 100 milliwatts during transmission of data, and the battery life over 72 hours, with the efficiency less than 100 milliwatts during tests, a minimizing use of energy. The low power mode will automatically activate after 5 minutes of inactivity, and the power demands will be less than 200 milliwatts. And with the charging time less than 3 hours, with USB-C or wireless of 5 volts. With the supercapacitor, the voltage will be around 3.5 volts, and the PMIC for LiPo battery, the capacity will be 500 or 600 milliamperes per hour with a charge voltage of 4.2 volts, with a discharge and voltage of 3.0 volts. The Bluetooth low energy module will range typically around 50 meters and can change due to environmental factors, with a current consumption of 10 milliwatts, and the energy consumption is set to be minimal. Also, the communication, the representation of the frequency type input and output to emitter and receiver. We have the Apollo 4 Blue Plus with a frequency of 100 millihertz. And the common filtering, the type input generally refers to the bioimpedance sweat sensor temperature along other data sensors. The Bluetooth low energy module is the emitter. The emitter is the wristband. The input includes the hydration levels, sweat sensors, bioimpedance sensors, and other sensors used in the wristband. And the output is the data collected of the hydration status. The receiver will be the smartphone or device receiving the collected data, and the input is the info received from the wristband, and the output is the notification sent and feedback to users. With the controls and with the representation of input and output signals, the Apollo 4 Blue Plus input signals are analog sensor data and digital signals, and output signals are the digital and analog output for sensors. And the common filtering, the input signals, sensors measurements, sweat sensors, temperature, etc. And the Bluetooth low energy module, the input signal is, in this case, the process data. Meanwhile, the output signal is the data transmission.
Okay, now I'm going to be presenting the manufacturing and integration plan and procedures. First, we're going to start presenting the drawings for the assembled wristband. Here we have the front, the back, and a lateral view of the complete wristband with the respective dimensions, and all the designs were made following the ANSI Y14.5 standards. And the overall materials for the wristband is plastic, more specific polycarbonate, and medical grade silicone for the strap. Again, we have the 3D design of the wristband. We have the front, the back, and the lateral view. And the same as before, it was made following the ANSI Y14.5 standards. The previous design was made to show the manufacturing process and to show the final result of the process. Here we have again the wristband with the numbers corresponding to the item number with the specific component description, dimensions, and quantity that will be needed to produce 1 unit. This is the bill of materials. First, we have the number 1, which corresponds to the polycarbonate casing, which is going to be made in injection molding. And here we have the specific dimensions, and we're going to be using just one set. The number 2 corresponds to the OLED screen, which is the display. We have the dimensions again, and it's just going to be one screen. And the number 3 is the rubber button. The number 4 corresponds to the silicone straps. The number 5 is the spring bars that we're going to be using to attach the silicone straps to the polycarbonate casing. The number 6, number 6, which is the LiPo battery, number 8, which is the Apollo 4 Blue Plus microcontroller, the number 9, which is the PCB, and the number 11, which is the wiring and connectors, are here inside the polycarbonate casing. And for the number 7, we have the sensor, which is going to be inside the casing, but it's going to have a part in the outside to be able to be in contact with the skin. And finally, we have number 12, which is the adhesive and fasteners to be used to bonding and securing internal components. And as I mentioned before, here we have all the dimensions and the quantity for every part. Now I'm going to be presenting the manufacturing. On the left, we have the summary of the manufacturing and process. The first steps correspond to selecting the manufacturer part. We have the polycarbonate casing, the rubber button, the silicone strap, and the purchase components. And in the site, we have the pictures of photos corresponding to each one of those parts. The second step will be the drilling and cutting, or the drill and prepare components. We have drilling, which include drilling the holes in the casing for the sensor, the microcontroller, and the button, and also drilling the holes in the silicone strap. And this is going to be made using the CNC machine and the drill press. The second step is the assemble electronic components, which include to attach the OLED screen, to integrate the sensor, install the battery, mount the microcontroller, and finally writing on the circuit integration with the electronic components and soldering if needed. And finally, we have the step number 4, which is the final assembly and sealing, which include to close the casing and to secure with adhesive bonding and applying waterproof sealing like the epoxy resin, and attaching the silicone strap and securing it with the spring bars. And at the bottom, we have the results, including the raw materials, the overall raw materials, which are the PC resin pellets, the OLED screen, and the silicone straps, to be able to have the finished part of final result, which is the hydration monitor and wristband, the complete piece. The manufacturing, as I mentioned, we have all the materials with the corresponding dimensions, like the polycarbonate casing, the OLED screen, the rubber button, the sensor, the battery, the microcontroller, silicone straps. And here we have the assembly process, which include preparing the components, installing the OLED screen, integrating the sensor, placing the battery, attaching the rubber button, wiring and the circuit integration, sealing and enclosing the wristband, attaching the silicone strap, and finally, a final testing and the packaging and quality control. Now Gabriela is going to be talking about the user manual or system operation plan.
So for the user's manual, we have each step that we need to go follow, and the first one will be wearing the wristband, how to place the wristband, how to properly do it. The second step will be powering the wristband on and off. So we're gonna specify how to turn off or how to turn on the wristband. We have the charging wristband, that is how to connect the charger. We also have how to sync the wristband with the app in order to you to see the hydration data and set up the personalize the app. Now we're gonna have Jose Martinez. He's gonna talk about the performance estimates.
Yeah, the performance estimates for this device should be lightweight. The explanation is it should weigh around 1 to 2 ounces, and the expected materials are lightweight. The compliance was met in phase C1. The low power consumption will use the minimum energy was also met in phase C1. The safety requirements that should comply with the FDA and HIPAA guidelines. The with edge computing with embedded analytics was met also in phase C1. The reliability was met in phase C1 and phase C2 using a hybrid model with edge computing and cloud-based analytics. And the producibility and cost, the average cost of the materials should be less than $30, $30 was also met in phase C2.
So now we have the system budget. We have item number 1 through 12, the component description, the polycarbonate casing, the OLED screen, rubber buttons, silicone straps, spring bars, LiPo battery, the sensor, the Apollo 4, the PCB, the charging port that is going to be USB-C, the wires and connectors, and the adhesive. We also have the dimensions and the quantity per unit. The estimated cost per unit is already in there too. So we have the polycarbonate casing per unit is going to be 120, and the estimated cost per 10 units is going to be 10,000 units is going to be 12,000. And we also have the supplier that is going to be Savic, and for each one we have the estimated cost per unit, the estimated cost per 10,000 units, and then the suppliers. The estimated total cost per 1 unit is going to be 2660, and then per 10,000 it's going to be $265,000 per material cost.
Here we have the project plan. We have the top, the develop for phase 2 presentation, which is this one. Then we have for the phase, sorry, the phase D presentation with all the parts, and also the phase F presentation with all the parts. And one key activity, sorry, which is the final written report, the poster, and the certification. And also we have the corresponding dates, due dates for each one of them. For the phase D presentation, it's going to be April 18, and for the phase F presentation, it's going to be May 16.
Now we have the conclusion. In this phase C2 presentation, we present the hydration monitor wristband final design of the system. We show the integration of the interface and design the drawing for the entire system to be able to manufacture. In the same way, we establish manufacturing and assembly procedures, detail the operation plan or user's manuals, evaluated the performance estimates, and presented the system budget for the wristband manufacturing. Finally, we outline the project plan for the phases D and F, ensuring smooth progress towards the next step. This phase presents our designs and budgets, setting the stage for continued development. And those are the reference that we used. Thank you.
Thank you.